Nicotinamide mononucleotide (NMN) is gaining recognition not just as a longevity supplement, but as a promising metabolic modulator, particularly in the context of age-related obesity. This form of obesity is not simply a result of excessive caloric intake or inactivity. It's often a consequence of deeper biological changes that occur with aging, including impaired lipid metabolism, decreased mitochondrial function, and a progressive decline in autophagy. NMN, by replenishing cellular NAD+ levels, appears to revive key pathways that restore metabolic efficiency, among them autophagy, a self-cleaning process that plays a central role in lipid turnover and energy balance. The question now being explored is whether NMN-driven autophagy can effectively reverse the accumulation of fat that tends to accompany aging, and the emerging evidence offers a hopeful view. With age, fat distribution shifts in unfavorable ways, favoring visceral adiposity and ectopic fat deposition in organs like the liver and muscle. This is accompanied by a decline in adipose tissue's capacity to break down stored lipids, a process known as lipolysis, and reduced turnover of lipid droplets within cells. Autophagy, particularly in the form of lipophagy, the autophagic degradation of lipid droplets, is one of the body's natural tools to clear these excess fats. However, autophagic activity diminishes with age, contributing to fat accumulation and metabolic dysregulation. NMN supplementation reactivates this process through the restoration of NAD+, which in turn activates sirtuin-1, SIRD1, and AMP-activated protein kinase, AMPK, both of which are essential regulators of autophagy and lipid metabolism. Animal studies have demonstrated that NMN not only improves insulin sensitivity and mitochondrial function in aged, obese mice, but also reduces fat mass, particularly in visceral and hepatic depots. These effects are closely tied to enhanced autophagy, as evidenced by increased expression of autophagy-related genes and greater turnover of intracellular lipid stores. By stimulating lipophagy, NMN helps cells liberate fatty acids from stored triglycerides and redirect them into mitochondrial oxidation, a cleaner and more efficient form of energy production. This mechanism is especially important in the aging context, where energy production tends to be inefficient and easily overwhelmed by lipid overload. In addition to promoting fat breakdown, NMN's influence on autophagy supports the remodeling of adipose tissue into a more metabolically active state. There is growing interest in its ability to enhance the browning of white adipose tissue, a process by which energy-storing white fat takes on characteristics of energy-burning brown fat. Autophagy is known to be involved in the formation and maintenance of beige adipocytes, and NMN-induced NAD+ restoration may support this thermogenic transition. This shift not only reduces fat mass, but also contributes to higher basal energy expenditure, a factor that becomes crucial as resting metabolic rate declines with age. Moreover, NMN's systemic effects on inflammation, oxidative stress, and mitochondrial biogenesis create a favorable environment for sustained fat loss. Chronic low-grade inflammation, a hallmark of aging and obesity, interferes with both adipose tissue function and autophagic activity. By dampening this inflammatory milieu, NMN helps restore the cellular homeostasis required for efficient fat metabolism. In tissues such as the liver, where fat accumulation can lead to non-alcoholic fatty liver disease, NEFLD, NMN has shown potential in reducing hepatic steatosis through enhanced lipophagy and mitochondrial renewal. Early human trials are now exploring whether these effects translate beyond rodents, and the initial results are encouraging. In older adults, NMN supplementation has been associated with improvements in muscle insulin sensitivity, energy metabolism, and physical performance, all indirect indicators of improved fat utilization. While direct measures of fat mass reduction and lipophagic activity in humans are still being investigated, the convergence of mechanistic understanding and preliminary clinical data suggests that NMN holds real promise in targeting the root metabolic contributors to age-related obesity. The concept that autophagy could be harnessed to reverse fat accumulation represents a paradigm shift in how we view aging metabolism, not as an irreversible decline, but as a set of processes that can be rebalanced through strategic interventions. NMN, by targeting the fundamental decline in NAD+ and reigniting autophagic pathways, provides a molecular entry point to that balance. It may not replace diet and exercise, but it complements them in a profound way by restoring the body's natural capacity to recycle and renew, which in turn supports sustainable fat loss and better metabolic health throughout aging. As research progresses, NMN's role may evolve from a niche supplement to a central player in personalized strategies for managing age-related obesity. The idea that a compound could not only delay aging but actively counteract one of its most visible and harmful effects, fat accumulation, is an exciting frontier. The integration of NMN with other metabolic and lifestyle therapies could ultimately redefine how we treat obesity in the aging population, not just as a cosmetic or cardiovascular issue, but as a deeper problem of disrupted cellular recycling and energy homeostasis that can potentially be reversed.